Let's take a seat. Let's get settled down and get in the class time. All right. I'm gonna hit a schedule like 3 minutes on questions. Probably 3 questions. Any other type of questions? Do you sit in more or less the same spots? I see familiar faces in familiar places, just less of you. Let's try it. You're all here. And? Oh, don't say yeah.
So we can do like a regular expression example?
No.
Fine.
Not because I don't think that would be valuable. I think recitation sections would be an awesome place to do that, or office hours. Just because we need to cover new stuff today.
Okay, that's fair.
So like, yeah, if it's on syntax analysis stuff, like first sets, follow sets, any of those kind of stuff. I mean, we're getting to follow sets now, but I don't want to backtrack too much, and I don't know if I can do a good regular expression example in like the 1 minute left that I have.
Do you have any examples of it on your on the web on the YouTube at all, or probably in like previous classes or something?
Yeah, maybe. Yeah, send me an email, and I can look through and search through all my past videos. I'm sure we've done it at some point.
Okay, thank you.
Or I don't think there's a class in here after class, so maybe afterwards you bring up your question again, and maybe I can do a quick example after class. That way I can record it. Cool. Okay, any other questions? Yeah.
Are we still doing parsing techniques, or are we done with that?
We are going to close that up. We have to do follow sets. What's this? I just have the slides up. Syntax analysis. Yeah, so we need to cover follow sets so we can do parsing, so we can actually do how to write a predictive recursive descent parser, which we haven't talked about. So how we can actually write that parsing code that we saw based on any grammar once we calculate first and follow sets. So we're going to do that, and then we'll be done with syntax analysis. Then we're going to move on to semantics, which is really interesting. Cool. All right, let's get back to it. Okay. So we kind of talked about, and on Wednesday we talked about and developed our intuition behind. We kind of saw that, hey, just using first sets, I can't actually tell if I can parse a grammar or parse a string. So create a parse tree given either, you can think about it, a string or a sequence of tokens just by peeking ahead by one token, right? And we saw that we need this new function called follow that represents what comes after a non-terminal, what kind of tokens can come afterwards. And so we talked about that the function signature for the follow function, it takes in this case, unlike in first sets where it took in a sequence of terminals and non-terminals, here we only care about the follow of non-terminals. And it's going to return a set of terminals and end of file. Intuitively, we talked about that at the very end where it crashed. The starting non-terminal, this is why it's good to be here. So the starting non-terminal will always have the end of file be followed after it, right? Because we just kind of know that we have S. It's going to generate any kind of random tree, any kind of rules are going to happen. That's going to result in some string or sequence of tokens. And we know that after that is end of file. So we know that end of file is always going to follow our starting non-terminal. Cool. Okay, so let's kind of develop, so we're not going to go into rules just yet, but let's use this as an example to try to think about what follow means, right? Or what should it be based on our understanding of what the semantics of the follow function is and what this grammar looks like here. So we have S goes to A, B, or C. A goes to little a, B goes to big B, little b, B. C goes to C, little c, or epsilon. So the first thing we want to ask ourselves is, okay, so what do we already know just from looking at this grammar? What can we know about some information that we know about some of the follow sets here? Any bits of information?
A will be followed by end of file.
A will be followed by end of file. Why?
This doesn't have any other non-terminal.
So tell me what rule you're looking at here.
First is A is alone formula for S.
So like this, so S goes to A, that's the rule you're looking at?
Yes.
So then what do you know about S first?
This is going to end with end of file.
Yeah, end of file has to follow S, right? We kind of just showed that in that terrible tree diagram, right? So then why do you think now that end of file would be an A's follow set because of this rule S goes to A?
Because when you take A non-terminal, then there's nothing following after it.
Yeah, so if we go back to our tree, right? We know looking at that rule we have S. We know there's a rule S goes to A. And no matter what happens, right? The end, like all possible strings that S can generate is going to be the same as all possible strings that A can generate. And so whatever follows S here is also going to follow A. So yeah, that would be a good thing. So we would think maybe the end of file would be an A's follow set. Does that apply to any of these other rules? Yeah.
B in the second.
Yeah, and S goes to B, right? It's the exact same situation, right? So that would mean based on our previous logic and reasoning, end of file should probably be in B's follow set. So it's the same true for C. Yeah. There's no difference there, right? And so one of the key things I want you to think about that we're thinking about now, right? When we do first sets, we're looking at, if I want to calculate the first set of S, I look at all the places where S is on the left-hand side. But here, when I'm talking about follow, I care about where is that non-terminal used in the grammar. So where is it in the right-hand side of rules? So what else can we know about that? So okay, we got some pretty good information there from looking at the first rule. What other rules? Or what, not rules, but what other things? Little b is in the follow set of B. Why?
Because it goes big B, little b.
It literally follows, right? It's directly after. We have a rule, and we don't care what's on the left-hand side. We know when this rule is chosen, right? If we go back to my example, right? It doesn't matter what happened up top. It just happens to be that this is a B. It doesn't really matter. But we know that that's going to generate a B and always a little b when this rule is chosen. And so whatever b generates, we know that what follows it is definitely going to be this little b. And we don't care when it happens, we just know that this rule exists. Therefore, there is some possibility that a small b can follow a big B. Cool. So we have in B's follow set now the end of file and little b. So what else? Any other information we can know based on our reasoning and logic?
Little c follows c.
Yeah, by the same reasoning, little c also follows c. Right? Cool. So let's see. Oh, look at us. We're so smart. We just did all this. Okay, but this is just like eyeballing it, right? And kind of trying to develop some intuition. So let's think about what we were doing when we came up with those rules to try to understand and think about the rules themselves. So this is not, I'm going to just do a whole new thing. So I'm getting much better at this. Cool. Or maybe you don't think so, but I think so. Oh, Windows resizing. Cool. Okay. Sweet. Okay. So I had this rule. I have S goes to A. So wait, what was the first thing we knew that we just talked about? What is that one bit of information we started with? End of file is what? Right? So starting non-terminal, so we know that, right? We've just basically proven that by a terrible drawing. And it makes sense, right? S generates the entire string. So there could be, can there be other things that follow S? Not in this grammar exactly, but maybe in a different grammar, right? There's no restrictions on where S can appear on the right-hand side of a grammar. We could have S appearing all over the place, right? But we know that S, the starting non-terminal always has the end of file in its follow set. Boom. Okay. So let's think about this. So for our second, when we just went through this, we had S goes to A. What did we do there? So what did this tell us? Sorry. What did this tell us about A's follow set? Yeah, it should be the same as S? Exactly the same, or talking about sets, right? So yeah, it needs to contain, right? And why? Because we can see here that S will generate an A, and then so that anything that could come after S can also come after A. But we need to think, right? If we're trying to derive like a general rule, we want to think about the different cases, right? So is this only rules of the form S goes to A? Or if we said A goes to B? Does it still apply? What if we threw an alpha before, where alpha, as we're using again, is a sequence, 0 or more symbols? And what about would it apply in this case? Or more cases, I guess there's one more. Alpha, B, alpha. I guess they shouldn't be this thing, technically. We'll go with O, delta, whatever. Right, just some sequences. So does this apply to any non-terminal? So I have 4 choices here. A goes to B. So the rule, right, that we kind of derived was if we have something of this form, we can add, so this would be basically add first of A, sorry, not first, follow of A to follow of B, right? So that's what we came up with base of this, right? So here we're adding, so this is like a rule in this form. A goes to B. So we have B, so we add the follow of S to the follow of A here. So can we extend this rule? Can we think about extending this rule to any of these other circumstances? Does it make sense? Or is it just rules of this form? Do you want me to draw trees? You want me to draw trees? I can see it in your eyes. Cool. So we saw this case, right? A went to B, which went to whatever. And we know that whatever came after A is the same thing that comes after B. Definitely in this case. Well, let's go to this case. I have alpha, which could be any number of things. I have a B, and then I have a delta, which is any number of things, right? So this could go to anything, this could do anything, and this could do anything. So does this tell me anything about the follow of A? Like, how do I relate follow A to follow B here?
Follow with B has follow with A in it.
What was that?
Follow with B is going to contain follow with A, so everything that follows A also follows B.
Will it? What if this delta is just a lowercase a? Right? Because delta can be a sequence of terminals and non-terminals. So if it's just a lowercase a, then by our other reasoning that we talked about, well, we know little a should follow b here. That's the only information we can gather here. Right? So we have follow a tells us what happens here, right? After this whole thing. But does it tell us anything about what follows b?
No.
Not necessarily. Okay, so that's this case. Try this case. A. A, B, alpha, sequence of terminals and non-terminals. B develops anything, delta can go to anything, and fundamentally the follow of A tells us something here. So again, we kind of have the same thing. So does the follow of A tell us anything about the follow of B based on this rule? No. All right, so we have our final case. This is fun, I've actually never done this before. Delta creates anything. Oh, it's gotta look kind of like a tree. B goes here, and then A, right? A is this whole thing, so the follow of A is what's after here. So now does the follow of A tell us anything about the follow of B?
Yes.
Why? It's the rightmost of our rules, right? Because we know whatever A expands to, B is the rightmost, so whatever follows A must also follow B. Cool. So then we can actually extend our rule a little bit. So our rule is if we have something of the form of this. Oh, sorry. This is why I didn't use beta in this example. Right? If we have A goes to any number of sequence of terminals or non-terminals, then beta, add follow of A to follow of B. So let's revisit this diagram. Or, we'll go here. Let's revisit this diagram. No, sorry. I want to revisit this one. Right? So why did we rule this one out? Why did this not tell us anything? What condition caused us to rule this out?
There's a non-terminal after.
Yeah, maybe there's a non-terminal after B. But what if we got rid of that condition? Or what if we said, what if we knew that delta could go to, what would help us? Epsilon. And how do we know if delta goes to epsilon? Yes, if it's in the first set, right? If the first of delta contains epsilon, then what?
Then the follow of A is follow of B.
Yeah, then we should add. So we know, just like our diagram, right? If this can go to epsilon, there's a certain case where it will go to epsilon and go to nothing. And that means what follows A also follows B. So we have what? That was the second rule. So we basically have our second rule here. And maybe you notice some parallels. Right, let's think about like one, so we have A goes to, let's say alpha, B, let's do it a little bit differently. Let's say it's B, what do we want to call it? B0, let's say B0, B1, all the way up to BI. It's a little different from the notation we were using before, right? And so what condition, so similarly, remember how the first set rules, we were talking about i's and zeros and epsilons in first sets. So what would that mean? What would my equivalent kind of here be? So if I have the rule in this form, but I need another condition because we know I just can't I can't add the first of A to the first of B0 all the time. So what's my condition? Yeah, epsilon exists in the first B1 and B2 all the way up to epsilon existing in the first BI, all the way to the end. Right? Then add the first of, was it the first of A to the first of B? Yeah. Oop. Follow. There we go. This is the problem when you start mixing them. For some reason it's easier for me to write follow in lowercase. I don't know why. Okay. So just like on first sets, right? Essentially these two rules give us an algorithm. What does this rule say, this second rule? Like in English, kind of.
If B is not followed by anything.
Yeah, if it's the rightmost symbol, then always add the first set of A to the first set of B. So add the first set, the follow set of the left-hand side to the follow set of B. Rightmost. Well, the left-hand side, so you have the follow set of the left-hand side non-terminal to the rightmost non-terminal's follow set. We'll go over this in a second. It'll be a lot easier. And then this says basically, somebody's making it rain. It's not a very effective bribe if it's changed. All right. So this rule that we just came up with basically says, okay, if there's an epsilon in the rightmost, there's an epsilon in the firstmost of the right, there's an epsilon in the first set of the rightmost symbol, then we can add the follow of A to the follow of the next one, right? And this will keep going. Although this is actually slightly different, as we'll see how this applies, because we really only care about B0, because we're going to try to calculate first of S, first of A, first of B, first of C. So we do this and we say, okay, if I'm interested in the first of B0, well, if it's at the very end, I know I can always add it by this rule. And if there's epsilons in the first sets of everything after me all the way to the end of the rule, then I know I can also add the first of A to the first of B0. That's 3 out of 5 rules. It's pretty sweet. Okay, let's think about our second one here. So we had B goes to B, B little b. B goes to B little b. So what would this be like in a rule?
The rightmost of the right-hand side is the terminal, and that's in the follow set.
Yeah.
So the rightmost, okay, let's change it slightly. If I change this to A, does that change what you were going to do? So remember, what we're getting out of this. What's our goal here for this part? What do we add to B's follow set?
Immediate terminals.
Yeah, so what did I do? So what did we do here when we did it for this one? What did this rule tell us about big B's follow set? It has little b. And we know that, we talked about that, it's because it comes directly after big B. So does it matter then what this symbol is on the left-hand side?
No.
Could be A, S, B, D, doesn't matter at all. What matters is where B appears in the right-hand side of this rule. So this was we add, so what did we actually add in here? The terminal. It's like the next, so let's think about how this situation would change. So let's say I have this. This is a little c. Maybe we'll change it to d's. Oh, not again. Why does that happen? It's so weird. We're going back to c's. I wonder if I can undo it. Okay, there we go. Sweet. It makes no sense. Okay. So now in this, very similar, but what do I know about the follow of B?
First of D. First of D is D.
Follow of B is what?
First of D.
Which is what?
D.
The set containing D, right? So is that this? So the way you should check, right? And this is the way when you're trying to come up with an algorithm or think about things, right? Is okay. I added this guy, this terminal here to B. What was I really doing, right? In this case, are you adding this terminal? Like big D is a non-terminal, right? So it seems different. So what did you were adding what in this case? The first set of big D to the follow of B. Just like what you're doing here. What's the first of little b? The set containing little b. And you added that to the follow of b. So if you have a rule of the form A, it doesn't matter, goes to N, does it matter what comes before B? No, I don't care, right? Anything can come before, because I only care what happens next, right? What follows B? Literally the follow means we don't care at all about what comes before. So I have B followed by, we'll go back to C. Followed by delta, which could be anything, right? For this case, we don't really care about what comes afterwards. And so if we have this in this form, then we do what?
First of C will follow of B.
Cool. Right? And this makes sense drawing-wise, because we have A, we have whatever junk's happening here, we have a B, we have a C, and then we have delta. Right? So we know that this is going to generate something, and C is going to generate something, and what I care is what is the first thing that comes after B, and say, well, I know how to calculate the first thing that C starts with, and because C follows B in this example, then the first of C must be in the follow of B. So now, just like I did when we were doing rule 3, what case should I consider now?
Case where C has epsilon.
Case where C has epsilon, right? What if I have C or epsilon? Or here, whatever, B or epsilon, right? So just like right here, right? The idea is when C is epsilon, this thing goes to nothing. And so what follows B? The first of delta in this case, exactly. And since we're super good at this, we can write it in this form, right? So we have the fifth rule, which basically says if we have a form A goes to alpha, B, let's go 0, B1 all the way to BI. Wait, I don't write this. Oh, it depends on the general one. Yeah, okay, good. BI, okay, yes, this. BI plus 1 all the way up to BK, so this is all the way to the end. So let's say, so I want to add BI plus 1's follow set to B0. So what would that mean? Yeah, B1 through BI must have epsilon in their first set. So if the rule is of this form and epsilon exists in the first, sorry, my handwriting's gonna get bad because I want to write this faster. All the way up to then, just like before, I'm going to add first of B, which one? I plus 1 to follow of B0. That's it. That's all the rules, 5 rules. And yeah.
In case 4, and this might be obvious, but rule for why did we only add the first of C to the follow of B and not the first and the follow of C to the follow of B?
Because we don't know the shape, essentially if you think about it like this, right? We don't know the shape of whatever this tree is that C is going to generate, right? The first set tells exactly what characters can this tree, this string, this substring that this generates start with. But it doesn't tell us anything about how many strings and sequences there are, right? Whatever the third character is, or if C, let's say, always generates a terminal, then what delta starts with does not matter to the follow of B. Because whatever delta starts with can never follow B. So think about it like this. So if we have SA goes to B little c D, right? So I know that this rule, if this is my only rule, this gives me a parse tree like A, B, little c, D, right? So B can do anything. It can have first sets. The first set's going to tell me what character happens here. The follow set is going to tell me what happens after D. B will do whatever. The first set tells me what token B starts with, and the follow set tells me what comes afterwards. So does D's first or follow set affect B's here?
Yes. No. Why not?
Because there's a C here.
So we can't concatenate. Like I'm missing the point. Like why, if B or D follows B.
D follows, well, when we talk about follow, we don't want all the characters and all the tokens that can follow, right? We don't care about the sequence. Just like with first, we care about what is exactly that first character that could be there.
So every follow set will contain exactly one element?
No, it's only talking about the element that directly follows this non-terminal in the resulting string. So let's think about it like this, right? So like for first sets, so if I have A goes to B, C, D, right? When I think about it like a tree, I have A, little b, little c, little d, right? But the first set here, I only care about B. I know that all possible strings that A generates, they will only ever start with B, and I don't care what any of the other strings are that's in there. So similarly to follow sets, now we give an example. So if I have B goes to A, E.
So to answer my own question,
Sure.
Follow set can have multiple elements when the construction rules say that a single non-terminal goes to several different sets of terminals and non-terminals.
Yes.
That's when the follow set would have multiple elements.
Yes. So you could use, like, for instance, here you could have A goes to big A, little e, or you could have A, F. Whatever. There's going to be two, in all possible strings and combination of these rules, right? The only two terminals that can ever follow the A non-terminal in this grammar, and when I say follow, I mean directly afterwards, are either A or F. That's it.
E
or F. Yes. The first of little e and the first of little f. In this case, R, A, E, and F. You only care about what comes afterwards and just that first character, or first character terminal. So for here, that's why, because this C essentially occupies that next terminal after B, and it can never go to epsilon, it can't go to nothing, so it doesn't matter to look at D at all. Cool. We made a lot of progress. Awesome.
Wait.
No, I'm just kidding. Go ahead.
Just with the formal definition of follow sets, I didn't.
Oh.
Because it was formally defined on the first slide. I'm missing, so that thing that we just I had to come up with intuition that the follow set are just the set of things that immediately can follow. I don't know.
Exactly. Yes. Yes. So it's the set of terminals and or end of file characters that can appear immediately after the non-terminal A.
So So also to clarify, the end of file does not appear in every non-terminals follow set.
Correct. It may not. Yes. But it will appear in one of them.
At least one.
Always the starting non-terminal because of the first rule. So it seems like when you look at these, it seems like these rules are a lot more difficult than first sets, or maybe, I don't know, maybe you're different, but to me, I don't know, it seems a lot scarier, but actually they're a lot simpler. We have like, the first rule is super easy, always apply it, add end of file to the starting non-terminals. That's just like, you do that once and you're done. The second and third rule just basically say, they're basically like, the second rule is the case where you are the last element, and the third case is there epsilons between you and the last element? And the fourth and the fifth are about adding first sets, so these are also the similar type rules. So let's go through the example. Okay, so we need first sets. Why do we know that we need first sets?
Follow set.
Yeah, we need first sets for rules 4 and 5, and then actually end rule 3, right? So we need to calculate first sets first. Nice that they're named that way. So calculate first sets. So what does this mean when you're doing it on a test?
The first set, right?
Yeah, you should get the first set right, because it's going to mess up everything else. Also, programming. Is it worth it to start on follow sets if you're not passing all the test cases of your first sets?
No.
Probably not. I mean, it depends on how close you are to the deadline. You may have to do some like game theory things about how much can you get done. But you know, if you really need to and want to make your first sets rock solid, that way you know there's not a problem, right? Because once you start coding follow sets, now you have to start worrying about, is my logic for calculating follow sets correct, or did I mess up first sets? Right? So it's a lot easier to think about these tasks in terms of really different stages. Like stage 0 is really just all about you reading in the data into some data structures that you can iterate over and manipulate. Right? And once you have that, then you've read in all the data correctly, you're good to go to start doing first sets and to start calculating over that data. So anyways, that's how I suggest you approach it. Okay, so same thing like before. I'm not going to go into the example, but we have follow sets relying on follow sets. We don't want to get into any crazy recursive situations. So we're going to do the same way, start with empty follow sets for all non-terminals in the grammar. And then, just like first sets, we're going to keep applying all of these rules to all the first sets in turn until we get to a point where the follow sets do not change. And then we know we don't have any more information, and we're done calculating follow sets. So the rules are actually, I think, the way we wrote them, handwritten, and these are pretty much the same. So if S is the starting symbol of the grammar, then add end of file to follow S. Super easy thing to do, right? You only have to do this once, yeah.
Are these slides, I know they're in the video, but are this just the slides available?
Yes, they're online.
Because the last 4 lectures, I'm finding that my notes are basically a long series of construction rules with gibberish in between them.
Yeah, all these are online.
So when we go to implement this, I'm going to need the numbers. Okay, thank you.
Okay, and we talked about if we have a rule. So here I switched it around B's and A's a little bit, because here I'm thinking I want to calculate the follow of A. That's what I want to calculate. So if I have a rule of the form B goes to whatever, and A is the very last rightmost symbol in that rule, then I know I can add the follow of B to the follow of A. Then here, I guess I did it a little different. Then here, I care about A again, right? So I'm trying to say, what do I do with the follow of A? I say, well, if epsilon exists in all of the symbols after A to the end of the grammar, they can all go to nothing, and so we can add the follow of B to the follow of A. Right? This is the rule that we came up with. We use B0s and B1 through I. This is a little better way to think about it. It's a little more consistent. And of course, you can think about these C's as either, in this case, you can think about them as either terminals non-terminals, or you can think about them as symbols, right? Terminals or non-terminals, because your program is probably going to consider them as symbols in your grammar, right? But you can calculate if C0 is a terminal, you know is epsilon exists in the first set of a terminal.
What?
Does
No.
epsilon exists in the first of little a?
No.
No, it can't, right? The first of little a is the set containing a. You already calculated it when you calculated first sets. Okay. So then these two rules basically say, how do I propagate follow sets from the from the left-hand side symbol to something on the right? That's essentially what these are saying. The next rules say, okay, what about where a is actually used itself? Because I know a rule in this form is telling me that C0 follows a. Right? And so this rule, okay, good. So this is something we didn't talk about when we were doing the first sets. Why do we subtract out epsilon here?
Epsilon can't exist in the follow set.
Yes, epsilon cannot exist in the follow sets, right? Follow set is terminals and end of file. That's it. Right? And so you can think about this. Rule 4 is another base case. You always, if you're calculating the follow of a, add the first set of whatever comes after it minus epsilon to a's follow set. Always do that 100% of the time. And then the fifth rule basically says, okay, but if there exists an epsilon in first of C0, then you can add the first of C1 minus epsilon to the follow of a. And if there exists a epsilon in the first of C1, you can add the first of C2 minus epsilon to the follow of a. And if there exists an epsilon in the first of C2, I don't even know if I'm saying it right anymore, but then you can add the first of C3 minus epsilon to the follow of a, right? Just like adding first sets, right? You keep going until one of these symbols has an epsilon, or does not have an epsilon in its first set. Right? Because, so let's think about C0, C1, C2, right? So or maybe even C3. So by rule 4, we will always add C0 to A. We will always add the first of C0 to the follow of A. Makes sense. It's literally going to be that, right? But there exists a case where C0 can go to epsilon, to go to nothing, which means that the first of C1 is going to follow A. But there's a case that C1 could go to nothing as well, and that means that in that case, the first of C2 will follow A. So what happens if there's epsilons all the way C0 to CK? What do we do?
Add in the file. First of B to, follow of B.
Yeah, it's rule 3, right? It's crazy. You don't even have to worry about it. It's kind of already done for you.
And you union in the first of each C to the
Yes.
follow of A as you iterate through them.
Yeah. Like just like when we calculate first sets, we're adding to these sets. So the sets are only growing bigger. Yeah.
In the fourth rule, why are we subtracting epsilon from first of C0?
Because we don't have epsilon in the follow sets. It doesn't make sense. As we define follow sets, we only care about, can I get to that quickly? We only care about terminals. Terminals and end of file. Cool. So we'll go through an example. All right, we'll go through our handy dandy example that we used last time. S goes to A, B, C, D. A goes to C, D, or little a, big A. B goes to big, little b. C goes to little c, C, or epsilon. D goes to little d, or D, or epsilon. I'm sure you all remember this. These are the first sets that we calculated. It's in your notes, right? You just go back. Just kidding. Right, so we need these here, so we just keep them here kind of as reference. And then we follow our algorithm, right? So we're going to first initialize all the follow sets to the empty set, except for, well, I guess, all right, we can do this. Cool. Okay, so we have all the rules on the top. Oh, hello. We have all the rules on the top of the grammar, and we have all the first sets. That's all the information you need. Okay, so we're calculating the follow of S. Which rule applies? 1, right? Rule 1 applies. S is the starting symbol of the grammar. We add end of file to the follow of S. Okay. Then how do we apply rules 2, 3, 4, and 5? Where do we apply them to? What do we care about?
Right-hand side.
Right-hand side. So we need to find rules. So, and the important thing in here, I know it's going to bite some of you. We want to find all the instances where S appears in the right-hand side of the rules, and then apply all these rules to all of the instances. Right? So if you think about a case like A goes to B, little b, B, little c, what would be in the follow of B here? Right? It should be B and C. Right? Because you only care about the follow of B, so you're saying, what are all the possible terminals that could follow B? And here, even though there's B in this one rule, right, it appears twice. So we'd have to apply rules 2 through 5 to this B, and then apply rule 2 through 3 to this B. Yeah.
To be more general, we need to find all instances of where the left-hand side appears in the right-hand side. Because you said S, because we were concentrating on S. But if anything is ever in a left-hand side, we need to study all of its instances in the right-hand sides and apply the rule to each instance.
Yes, so it's all, so you can think of the things that are on the left-hand side are all of the non-terminals. But here's a specific difference in why I make this distinction. When calculating first sets, we look at, like if we were calculating the first of S, we look at all rules where S is on the left-hand side. Those are the only rules we care about. But when calculating follow sets, we look at where does S appear in the right-hand side of rules. So we have to look at every single rule to see if S appears anywhere. And here we see S does not appear anywhere, so none of rules 2 through 5 apply.
So if our production is A gives B, B, then in the follow side of B, first of B will be
Yes. Yes. The question is, if we have a rule A goes to big B, right? So by rule 4, it would say if we were looking at this instance of B, we would add the follow of B, the first of B minus epsilon to the follow of B. And then when we look at this instance, we'd see that rule 2 applies, and we would add the follow of A to the follow of B. Yeah, it's important. Cool. So follow of S and a file. All right. Very good. Why are we doing this? Oh, okay. We're talking about A. So now we're talking about A. So how many rules does A appear in, the non-terminal A appear in the right-hand side? I know counting hard. Right? We have S goes to A, B, C, D, and A goes to little a, big A, right? So there's 2 rules. So we need to look at each instance in turn. So we look at the first one. And we say, is S the starting symbol of the grammar? Or is A the starting symbol of the grammar? No, right? It's not going to apply. You can also think of this as, instead of considering this rule every single time, you just initialize the starting non-terminal with the end of file. That could be a different way to do that. Then we say, does rule B apply? Is A the rightmost non-terminal? Or, sorry, not even the rightmost non-terminal. Is A the rightmost symbol in this grammar? This rule, sorry. In this rule that we're looking at right now? No, so rule 2 doesn't apply. If rule 2 doesn't apply, will rule 3 apply? Oh, maybe, sorry. Okay, so then rule 3 says, so rule 2 says, am I the last one? If no, then is it possible for me to be essentially the last one, because there's everyone after me, all the way to the end of the rule, can go to epsilon, can go to nothing. So it's the same thing as if I was the last symbol. So are there epsilons in the first set of B, C, and D? Nope. You get stopped at B, so rule 3 doesn't apply. Rule 4, so we add the first of what to the follow of A? First of B minus epsilon, so B to the follow of A. And then we say, does rule 5 apply? Is there an epsilon in the first of B? No, so I'm done. Rule 5 does not apply. Cool. Then I have to look at this other rule. Right? I have to remember I have to look at every instance of A in the rules. Oh, are we over time? Oh, shoot. Oh, I know, me too. Alright, we'll go over this example again. I'll just like, I don't know, go through it in slow motion when you're watching this video at home and pretend that I'm saying witty things